All right, let's roll. Where did we end last time? Yeah, we're going to look at lesson 1, TBF, to be finished. This is on set theories, right? On set theory. And the last thing that we talked about was what? Yeah, we talked about a direct proof of A subset B. Okay, you remember the first thing that we did? We take a general element of A, we do some work, we conclude, therefore, X is an element of B, and then we say, thus, by definition of what it means to be a subset, A subset of B. And then if you wanted to, you could put the little box at the end. You ever seen a rapper drop a mic? Yeah, they like walk up and they're like, boom. When a mathematician puts that at the end, it's the equivalent of dropping a mic, right? You could also put QED. That's another way to do that. Okay. So let's look at an example of this. So this is example. Mike, could I get your help? Could I give you keys? I forgot an eraser, and there's no eraser in this room. Do you think you could find one somewhere? Thank you. Yeah, got it. Example 1.5.12. This is going to be proof, an example proof for a subset. Okay, so we're going to say let A be the set pi over 4 and 9 pi over 4. And then we're going to find another set to be B, which is going to be the set of all theta. Theta, 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 theta. That's what they say in that song, right? 4 cosine of theta minus pi over 4. Any hip-hop heads in the house? No? We'll fix that for sure. All right, so then we're going to say that that's the second set. And then we want to show that A is a subset of B. So my claim, let's do it real quick. We're looking for all theta in this interval such that this is true. Let's check. Pi over 4. Pi over 4 minus pi over 4 is 0. Cosine of 0. 1 times 4 minus 4. Okay. 9 pi over 4 minus pi over 4. 2 pi. Cosine of 2 pi. 1 times 4 minus 4. 0. Okay. So we just checked. We did that individually. Let's go ahead and do this. So to prove A subset of B, what do? We follow our nose, like Toucan Sam, but very different, right? What's the first thing that we do? What's the first step of that thing? Okay, so suppose X is an A. What does that immediately mean by element enumeration? X is equal to either pi over 4 or X equal 9 pi over 4. All right, so we had, what are we working on right now? The end of set theory. What are we trying to do? An example of a subset proof. All right, so we have two proofs, and the claim is that every element in this is also an element in this. What do we do when we start a subset proof? We assume a general element in this, and then we do some work, right? All right, so the moment I say that X is an A, what two choices do I have? This one or this one. So let's start with the first one. If X equal pi over 4, what must be true about that? That implies that cosine of theta minus pi over 4 is equal to the cosine of 0. Sorry. Which implies that the cosine of pi over 4 minus pi over 4 is equal to 1. All right? And then if I multiply on 4 on both sides, I get 4, which means that the cosine of pi over 4 minus pi over 4 minus 4 is equal to 0, which means that immediately pi pi over 4 is in what set? It must be an element of B, because that was the proposition that defined B, right? Are we done? Why not? Yeah, so the other one, we look at case 2. So we say, what's the other case that might be possible? All right, and that means that 4 cosine, I guess we're good at this enough now that we can probably skip a few steps, right? Minus 4 is equal to, well, let's be a little slower on this one. Sugar. It's called good board management. So this implies that 4 cosine of 9 pi divided by 4 minus pi over 4 minus 4, what's that equal to? Well, this is going to be 4 times the cosine of 2 pi minus 4, which is going to be 4 times 1 minus 4, which is 0. What does that immediately imply? Is in B. Okay. Thus, we showed if x element of A, then what must be true? X is in B, which implies A is a subset of B by definition. All right, should we drop the mic? We walk away, right? It's a lot sexier when rappers do it, I'll tell you that much. But it's the same type of ego.